we use a molecule called JQ1 from my laboratory that we previously had demonstrated could inhibit a specific protein called BRD4 that's very important for cancer. But we learned that the molecule also inhibits a related protein called BRDT. Now, BRDT has yet no role specifically in cancer, but is very important for the maturation, the development of mature sperm. And so we wondered, could the JQ1 molecule, intended initially for cancer, have activity as a male contraceptive agent? And in this study, we test biochemically, structurally, physiologically, developmentally, the effects of JQ1 on the formation of sperm and its efficacy as a contraceptive in mating studies in rodents. There was substantial human genetic evidence and some additional and important research from Columbia University from the Wohlgemuth Laboratory that had implicated BRDT, the gene, in the process of making sperm. The challenge with these types of genetic studies is they don't necessarily prove that a drug targeting the BRDT protein could have efficacy as a contraceptive and importantly be reversible. And so I suppose we hoped more than expected that the compound would decrease sperm counts. We were admittedly very excited when the Matzik laboratory reported back that the substantial effects on male fertility were purely reversible. JQ1 is a prototype drug created here at Dana-Farber, initially for study of the BET family of proteins that includes BRDT as cancer targets. We had not, at the time we made JQ1, completely optimized it for its drug-like properties. And so no, JQ1 is not intended for human use as a male contraceptive agent. However, the structural and biochemical and functional data provided by this paper are effectively a blueprint for developing a drug-like derivative of JQ1 that could be very potent and specific, very soluble, orally bioavailable, namely drug-like. And such a molecule we expect would have similar, if not more efficacious functions in developmental models and perhaps in humans.